Okay, so we are going to display the years from 0 to 25 here. So we have from 0 to 25. If we want to print numbers, the years from 10 to 25, we use this, uh, so 10 to 25. Now here, it is this one. So it is similar to this. So this one is also simply integers from 5 to, okay. So we have 5 to 15. We can also display the numbers or the integers from uh, example 12 to 20. We have here 12 to 20. We're using this command if was this I1 for the one. Or we can also use this one. Display integers from in the integer to in a larger integer. For example, you want to display numbers from 1 to 10. And I here I is 1 to 1. Okay, so we have the increment of 1 here. 1, 2, 3, 4, 5, 6, 9. Now, if the increment is equal to 2, so it becomes all even numbers. But you start from 0 here. So you have 0 to 4, 6, 8, 10. Or you can have also start. Because the increment of 3. So we start with 0, 3, 6 to 30. Now we can also start from 1, like this one. 1 for 1 plus 3 equals to 4, 4 plus 3 equals to 7. 7 plus 3 equals to 7. Okay, so we have here the next problem is finding the sum. For example, the problem here is stop the sum at 15. Example here, our problem is stop the sum at equal to 15. So 1, 2, 3, 4, 5, 6, 7. But at 5, you have to stop because the problem here is you have to stop at uh, greater than 10. No? Right, greater than 10. So we have here greater than 10. Okay, so we have 15. So, so this is 15. Now, if you want to express this greater than or less, greater than equal to 10, so it becomes only 1, 2, 3, 4, 1, 2, 3, 1 plus 2 plus 3 plus 4 equal to 10. Because the sum here is greater than or equal to 10. Okay, so we have also here. So we can solve that using the reduce. For example, here, if we have the formula here, n over 2 times the first term times plus the last term is equal to the sum of the integers from 1 to uh, from 1 or from any integer to any greater integer. For example, here, first term is equal to 1, and the last term is equal to n. So n is equal to the number of terms here. So we have this formula. So if the sum is greater than or equal to 10, so we have only n equal to 4. So we have 4 terms only, like this one. 1, 2, 3, 4. But if we have uh, greater than 10, for example, n times n plus 1 over 2 is equal to delta z. So what we have here is n should be greater than or equal to 5. So you add 1 here, example here, add 5 so that it becomes 15 like this one. Because that uh, our problem here is find the sum greater than 10. So it becomes 15 like this one. Okay. So if it is greater, so we use the 10. If it is equal or it is greater or equal to 10, uh, then it becomes 4 only. So this one becomes 4, like this one. Uh, at the equal sign here. So that becomes 4. But if you remove the equal sign, it becomes 5. So what, like what we have here, 5, 5 terms, so that is equal to 15. But if it is only 4 terms, if it has only 4 terms, then it is just equal to 10. So we have here the sum from 1 to 4 equal to 10. The sum from 1 to 5 equal to 15. Now we have here another problem. The problem here is the sum greater than 50. So so we have the numbers here, the integers from 1 to 20. But you have to stop here if the sum is greater than 50. So the answer here is equal to 55. So like what we have here, greater than or equal to 50 here. So you have to break this. Okay. So our integers here are from 1 to 10. So the sum is equal to 55. Okay. Now we can use this to find the value of n here. So the value of n here is equal to 10. Because if the sum is equal to 10 here, so it becomes 55. Okay. Now if this is only 9, it becomes only 45. So that is less than 50. So it should be at least greater than 50. So it becomes 55. So uh, our solution here is n equal to uh, n is equal to 10. So like this one. So this constant. So for example here, we are going to find another example here. We have 1 to 1,000. Stop at sum 1,000. So if the sum is 1,000, we have to stop there. So the answer here is sum. Sum is 1,035. Now we can also find the in here. So by using the this reduce, no reduce this is the formula for the sum of the integers from a lower integer to a higher integer. Now, if the sum is greater than 1,000, we have to stop there. So by using this equation, this reduce, we can determine the value. So n is greater than or equal to 45. Now here, if n is equal to 44 using the sum from 1 to 44 is 990. So the answer here is equal to 45. So the answer from 1 to 45 is equal to 1,035, like what we have here. 1,035. Now, here's how you use Mathematica in making multiplication tables. For example, you want to have a multiplication table, 5 by 5 here, so we have 5 by 5. We can have also uh, 4 by 4, or we can have uh, 10 by 10. So this is 10 by this is 10 by 15. So we have here 15 times 15 so 100. Example here, this example multiplication table. Example, you multiply uh, 3 by 7. So 6 multiplied by 7 is equal to 40. Then 10 multiplied by 8. So 8 times 10 is equal to 50. Now, if you want to write the square of the integer from 1 to 10, so we have to square the I here. So the output here is uh, 146, 149, 36. So these are the square of the integers from 1 to 10. For example, we have another example here, print the cube of integers from 1 to 10. So what we have here is the cube of 1, the cube of 2, the cube of 3, the cube of uh, the cube of 1, cube of 2, the cube of 3, the cube of 4, the cube of 5, the cube of 6. Okay. So, for example, we have a problem here. What is the first power of 2 greater than 100? The answer is 2 to the 7. Because here, 2 to the 7 is equal to 128. 2 to the 6 is 4. So greater than 100, so it should be 128. So the answer here is 7. Now we can uh, find the 7 here. So by 2 to the n is greater than 100. So the corresponding value for n is equal to 7. Greater than or equal to 7. Now the first power of 2 is greater than 100 is 128. So, right. What is the first power of 3 greater than 1000? Okay. So this is greater than 1000. Okay. Should be greater than. So the answer here is power of 3 greater than 1000 is. Okay, so problem here is what is the first power of 3 than greater than 1000? So we have here 3 to the n is less than or equal to 1000, and the first power of 3 greater than 1000 is 3 to the n. Okay, so we have here so the first power has value of 2187. So we have here n equal to 7, 2187, and if n equal to 6, 729. So our n here is equal to 7, because our problem here is the first power of 3 greater than 1000. So the first power of 3 is 7. So 3 to the 7 is 2107. So less than that, 6, 3 to the 6 is only 700. Okay. So we have here greater than or equal to 1000. The answer here is equal to 7. So if we equal to 7, so the answer is 2187. All right. So it starts from 7 and increases by 1. 7, 8, 9, 10. But the minimum here is equal to 7. So what is the power of 37 that is greater than 234? So we have here uh, 37 raised to the n is greater than 234, 129. So the answer here is equal to 4. So n to the 37 to the third power is equal to 50,154. But if n is equal to 4, it becomes 1,824, 161. So, okay, so we have here the if n equal to 4, like this one. So it is greater than 234,120. So what is the sum of integers from 1 to 100? So we have here by using this grouping, right? So what is the sum of integers from 1 to 100? Is this that or equal to 100? So the sum is 57. Now what is the sum of integers from 57 to 2341? So we start at I equal to 57 here, and the last term here is 2341. The sum is equal to uh, sum is 2,739,700. Or we can use the sum, no? We can use this sum formula. So we have the first term and the last term, and we have in here the number of terms. So the number of terms here is 2341 minus 57 minus 1. The first term is 57, the last term is 2341. So using the formula here, the first term plus the last term times the number of terms over 2 is 2,739. Okay, so display integers from 1 to 5. So just right here, they'll print I. I is from 1 to 5. Display integers from 1 to 35. Yes. We can simply write they'll print I 1 to 35.